Hello, thank you for watching the video on Colorado State University Mechanical Engineering Course 502 for Additive Manufacturing. This is a video for a 3D printed axial turbo machine. So the reason why we wanted to print an axial turbo machine was for instructional use. As this graphic can show you that there are many complex geometries and complex features within an aircraft turbine, and many of those concepts can help students learn the intricacies of turbo machine design, aircraft dynamics, and things like that if they had an appropriate tool that could accurately show them and have a hands-on tool so that they could be used to learn. The engine we decided to print is similar to this picture. It's a high bypass turbine commonly found on commercial aircraft. What that means is about 80% of all airflow through the main fan actually bypasses a combustion section, and 20% goes into the combustion section. So here, this is just a slip fit dry assembly of our 3D printed components comprising of our engine. The nacelle and internal fan blades were printed using SLA printer, and the base was printed using extrusion printer. The reason why the blades and major engine components were printed using SLA is because of the precision and accuracy of prints that an SLA printer can produce. By wanting to produce an actual instructional model that had actual accurate capability to it, and so it'd be an actual effective tool, required the need for a technique that could hold those tolerances. A lot of the common tolerances in terms of this project were the shaft, that everything slip fits around the shaft and has to spin on that shaft. So the SLA printer really allows for the parts to be printed relatively accurately with little post-processing needed to trim any of the flash or little small stuff off like that. The base was printed as an extrusion because the base pretty much just holds the engine in place so it doesn't roll off the table or something like that. The extrusion is a little less expensive, so in terms of a manufacturing standpoint, when it comes to choosing materials and choosing processes based upon a cost standpoint, the extrusion printer for a base is definitely more advantageous than wanting to print that unnecessarily out of a more expensive printer setup. Here we can see that even though everything is just sort of dry fit, the engine rotates quite freely and spins well. This is one of the benefits of using an SLA printer, is that accuracy and precision you get through the printing process enables parts to fit together quite easily. And so now we're just going to place the top cowling for the combustion section and the second top stator blade set and close the cowling for the final dry assembly of the engine that we decide to print. And that's the finished product. This is the 502 group that I worked with. Going from left to right is Sean, myself Alex, Phil, Kevin, Chris, and Derek.